At this point, we'll be looking at the rules for the Iupac nomenclature of organic compounds. What do we mean by Iupac? Recall, Iupac simply means the International Union of Pure and Applied Chemistry. Now, one thing I want you to know is that before you can actually name an organic compounds, your naming of organic compounds have to follow the rules of Iupac. It's a body that oversees the naming of organic compound. Now we have like 6 major rules we can actually take into consideration when we are talking about naming an organic compound. And the first rule we want to look at is rule number 1. The rule number 1 says select the longest continuous carbon chain as parent hydrocarbon. Select the longest continuous carbon chain as parent hydrocarbon, which is if I have a compound like C. Now, if I have a compound like this, now the longest continuous carbon chain is this. This is the longest continuous carbon chain. So the first thing is for you to select the longest continuous carbon chain, which is this. Alright, now let's look at the second rule. The second rule is that number the longest carbon chain. Number the longest carbon chain in such a way to give the carbon atom carrying the functional group the lowest possible value. Number the longest carbon chain in such a way to give the carbon atom carrying the functional group the lowest possible value. Okay, now what we are saying here is that the first one is to select the longest continuous carbon chain. Having selected the longest continuous carbon chain, the next thing is for you to number the longest continuous carbon chain. And when you are numbering it, you have to number it in such a way to give the carbon that is carrying the functional group the least possible value. Alright, let's see how to do that. Okay, now look at this compound here. Having selected the longest continuous carbon chain, now the next one is to number the carbon atom. Now let's number. The question is, how do we number the carbon atom? The rule is that you have to number it in such a way to give the carbon atom carrying the functional group or the lowest possible value. Now, apart from the functional group in the compound, we can also have an attachment, or we call it a side chain, which can be a methyl group, like this compound. So this is a methyl group attached to this compound. Now, in this case, if you are naming this compound, you have to name it or number it in such a way to give the carbon atom that is carrying this methyl the least possible value. So on that note, we cannot start from the right hand side and number to the left, because if I start from the right hand side and number to the left, I will end up giving the substituent the highest possible value. Let's see. If I start from here, this is 1, this is 2, this is 3, and this is 4. Now I end up giving the carbon atom carrying the substituent the highest possible value, which is against the rules of Iupac. So rather, I will choose to start from the left and number to the right. So here we have here 1, I have here 2, I have here 3, and of course I have here 4. Okay, now that is the second rule. Now let's look at the third rule. Indicate the other substituents by prefix preceded by numbers to show their position on the carbon chain. Indicate the other substituents by prefix preceded by numbers to show their position on the carbon chain. Okay, now what we are saying there is that if we have maybe other substituents, substituent can be alkyl substituent, like in this case we have methyl substituent here. This is a substituent. Substituent simply means a side chain, something that is not part of the compound. It's just an attachment. Okay, so substituent in this case is what? Methyl group. Now the question is that you indicate the substituent if the substituents are present in more than 2 places. For example, if I have a compound, take for instance this compound, we have a CH3 attached here, and I also have here CH3 attached there too. Now the rules is that after numbering the longest continuous chain, carbon chain, now the rule is that you indicate the substituent that is present by numbers to show their position. So here, if I want to give the name of this compound now here I have 1, 2, 3, 4. Now I will start with the substituent by indicating their position. So we have substituent 1 at carbon atom 2, we have substituent 2 at carbon atom 3. So this will be 2, 3. Now because there are 2, because I have 2 substituents attached in 2 places in the compound, so I will say di, and the substituent that is there is methyl, dimethyl. Then how many carbon atoms? 1, 2, 3, 4. That is but. Now we have only single functional group here, so that will end with ANA. So that will give us the name of the compound. And what is the name of that compound? 2,3-dimethyl butane. So that is the name of that compound. Now 2,3-dimethyl butane. So please, it's important that when you are naming this compound, you take note of the position of the alkyl group in that compound. Alright, hold on, I will get back to you later before we enter the rules number 4. Okay, welcome. Okay, now rules number 4 here. Don't forget, we are still on the rules of naming organic compound. Number 4, we say if the same alkyl or other substituent group occurs more than once as a side chain, show how many are present by using prefix di, tri, tetra, etc. and indicate by various numbers the position of each group on the longest carbon chain. Now here we are talking about the situation where we have a side chain or a substituent present in more than one place, in one position. Now here we actually ask to indicate the number present. If they are present 2 times, we can use di. They are present 3 times, we can use tri. Now look at this. In this case, we have the substituent 1, we have the substituent 2. They are present in 2 places, so we can actually use di because they are present in 2 places. So here we have methyl group at carbon atom 2, methyl group at carbon atom 3. So we want to name the compound. Now we have 2,3-dimethyl butane. So that's the name of that compound now. Now let's look at rules number 5. If there are several different alkyl groups attached to the parent chain, name them in alphabetical order. What we are saying here is that in a situation that we have several different alkyl groups, don't forget what alkyl group is. Alkyl groups are those compounds that are gotten from alkane by the loss of one hydrogen atom. For example, if I have a compound like CH3 or CH4, this is alkane. But if I remove one hydrogen atom from this compound, it's no longer alkane, it's alkyl. So here the name of this one is, this is methane. You can agree with me. Now this one is what? Methyl. So alkyl is gotten from alkane by the loss of one hydrogen atom. And one thing about alkyl is that they are normally used as side chain, just like in this compound here. You can see the alkyl here, you can also see the alkyl there. Alright, so question number 5 asks Rules number 5 says if there are several different alkyl groups attached to the parent chain, name them in alphabetical order. Now let's pick a typical example to illustrate what we are talking about there. Okay, now let's pick an example to illustrate that. You have my marker. If I have a compound on the board there, now rules number 5, remember, says if there are several different alkyl groups attached to the parent chain, name them in alphabetical order. Now look at that compound there. You notice that we have different alkyl group there. Starting from here, this is a propyl, this is methyl, this is ethyl, and this is another ethyl. Okay, now the rule is that if you have a different alkyl group in a particular compound, that we should name them in alphabetical order. So if I want to give the name of this compound here, okay, now here, this is ethyl present. So the first thing is to number the compound. So we'll actually start from my right, because we have more of the compound there at the right. So we'll have here 1, 2, 3, 4, 5, 6, 7, and 8. Now if I want to name this compound now, we have 2 ethyl present in 2 places. So that will be 3 rather. 3, because we have ethyl present in carbon atom 3 in 2 places. So we say 3 because they are present in 2 places. Now because there are 2, we use di ethyl. Now the reason why we start with ethyl is because we are asked to name it in alphabetical order. So 3 di ethyl. Now this is, we have a methyl here, we have propyl. So methyl M come before P. So 3 di ethyl, 4 methyl, 5 propyl, then octane. So this is the name of the compound. 3 di ethyl, 4 methyl, 5 propyl, octane. Number 6. Rule number 6 says if there are halogens together with alkyl groups attached to the parent chain, name the halogen first in alphabetical order and then alkyl group. Now look at this compound here. We have halogen. Halogens are group 7 elements. Group 7 elements are also used as side chain. We have a bromine, we have chlorine, and we have a substituent, alkyl group. Now the rule is that if you are naming this compound, you have to first of all name the halogen first. Now the same thing in numbering, you start from here because of the functional group and the halogen. 1, 2. So if I want to name this compound here, the name of the compound will be 1 chloro, 2. Now we have to also name it in alphabetical order. So bromine comes first. So we have 2 bromo, 1 chloro, 1 methyl, 2 bromo, 1 chloro, 1 methyl, ethanol. So that is the name of the compound there. So the name of the compound is 2 bromo, 1 chloro, 1 methyl, ethanol. Now we shall solve as many examples as possible so that you get a better understanding of the naming of organic compounds. Looking at these examples here, give the Iupac name of the following compound. Now we are asked to give the Iupac name of the compound here. Okay, now let's look at one.